Hi everyone, and welcome to my tutorial on recurring decimals and fractions. If you're new to my channel, I post tutorials on math topics to help with studying and revision. So today we're looking at decimals and fractions, but particularly recurring decimals, as they are a little bit more difficult. Just to recap then, some concepts on recurring decimals. So these are decimals that have a pattern of numbers which repeat forever. So for example, 1/3 would be 0.333333, etc. That's quite a straightforward repeating pattern of numbers. Often with recurring decimals, more than one digit repeats. Here we have a sequence of 1, 2, 3 repeating over and over again. The notation used for this, so the repeating part is marked with a bar or dots on top of the numbers. And if dots are being used rather than a continuous line, if there is only one dot, then only one digit is repeated. If there are two dots, then everything from the number with the first dot to the number with the second dot is in the repeating sequence. Two examples that we have here then, 0.34 but with the dot only above the 4 means 0.3444444, etc. Whereas 0.34 with both the numbers with the dots above means 0.343434. So that's just something to be aware of and to watch out for. Another example here, we have three numbers in the recurring decimal. You wouldn't typically put a dot above every number, it's just the first and the last. So here where it's 0.344 with the dot above the 3 and the dot above the second 4, you have 0.344344344. One of the typical exam questions that you may get is to convert a recurring decimal into a fraction. And one of the key things to watch out for is, does the reoccurring part of the decimal come immediately after the decimal point? Taking an example here, we have write 0.345 with the reoccurring dots above the 3 and the 5 as a fraction. So what we would do is just put this into kind of equation style format. We have let x be 0.345 and then we multiply. And because we have three characters that repeat in this sequence, we would multiply here by 1,000. And that gives 345.345 repeating. As mentioned, the key is to multiply x by a power of 10 such that one full repeated sequence moves to the left of the decimal point. And the reason we do this is because we can then subtract to eliminate the repeating part. So using the example that we have, if we take 1000x minus x, what this becomes is 345.345 recurring minus 0.345 recurring. And that nicely eliminates the recurring part, which gives us 999x equals 345. And thus we can quite neatly write this as a fraction. We can just put 345 above 999 and then simplify the fraction. What's slightly more complicated but uses the same methodology is when the recurring part is not immediately after the decimal point. In this example, then we have write 0.15, just the 5 recurring, as a fraction. We take the same thing, we put it in the equation format, and this time we start by multiplying x by a power of 10 such that firstly the non-repeating part moves to the left of the decimal point. So here we would have 10x equals 1.5 recurring. And then perform a second multiplication so that, like in the first example, one complete repeated sequence moves past the decimal point. And that would give us 100x equals to 15.5 recurring. The reason we do this, same as before, we can then create an equation that eliminates via subtraction the repeating part of the decimal. 100x minus 10x gives us 15.5 recurring minus 1.5 recurring, which quite neatly we can rearrange to give 90x equals 14, and thus we can write x as a fraction as 14 over 90 and then simplify to 7 over 45. You may, in an exam, actually be asked to do it the other way around. So convert a fraction into a recurring decimal. We have an example for this as well. Write 7 over 33 as a recurring decimal. Now, if the examiner is asking you to do this, hopefully they'll give something which you can quite easily convert into a fraction that has all nines on the bottom in the denominator. And then the top part of the fraction will tell you the reoccurring decimal. What I mean by this is if we convert 7 over 33 into equivalent fraction, which would be 21 over 99, then you know that the decimal is 0.21 recurring. Slightly more tricky. This time we have 5 over 111 as a recurring decimal, but same method. We convert that so that we have all nines in the denominator, in this case multiplying by 9 to give 999. 9 fives are 45, and this would give 0.045. One thing to watch out for here is you have 3 nines in the denominator. So this is not 0.45 with the 45 being recurring, it's 0.45 being the reoccurring sequence. This was a brief tutorial today, but really to target this trick with converting recurring decimals into fractions and converting fractions into reoccurring decimals. And I hope you've enjoyed it.